For this session, you will be learning the basics of C++ through the Arduino IDE. In addition, you will test your devices so far at the end of this session. To begin learning about the C++ language, you first need to know about variable declaration and expressions. Variable declaration is when a word or identifier is declared as a variable with a value and data type. When creating a variable, we format by type, followed by the variable name, and set it equal to a value. Another way to declare a variable is with no set value from the start. There are a few data types you should get familiar with. These are int, float, string, and char. When declaring a variable, we should use one of these based off of the value we are setting it to. For instance, we use string to represent words and sentences, and char for letters. As for ints and floats, they are used for numbers. We can use these variables in expressions such as number plus 1 divided by 2. What do you think this outputs? You will probably say 5.5, but the issue here is you are working with strictly integers, which are whole numbers. This results in the answer being 5 because when an operation uses only integers, but the result is a float, which does include decimal places, the answer is rounded down to the nearest integer. Now, take a moment to think about what the second line outputs. 3, right? But because there is at least one float in the expression, the output should be a float as well. You are now going to start a short activity based on what you learned so far. You should be familiar to the format of the code in the IDE, but here are a couple lines you will need to know. The first line is starting the transferring of data from the Arduino to your computer. The number inside is the baud rate, which is how many bits of information can be sent per second. This line should be placed in the setup function. I'll be talking about functions later on in this section. The next two lines are ways of sending data to the computer. They should be placed in the setup function if you want them to run once, or the loop function if you want them to run continuously. The objective of this activity is to create a string variable for your name, hometown, and favorite food. Also, an int variable for your age and graduation year. Take these variables and serial print them to your computer. In addition, add a delay if, else if, and else statements are an important aspect of coding. They work by running the code inside the brackets if their conditional statement is true. In this example, code number 2 is run because the variable num is equal to 10 and only the statement that is true is the second one. Now take a moment to look over the second group of code and decide which code will run. The answer is code number 3, because num is neither greater than or less than 10. Now take a moment and decide what happens during the next code. The answer is that nothing happens because the only conditional statement is whether num is greater than or equal to 11, which is untrue. Your next activity is to develop some code that will ask the user for a letter and prints the day of the week for that letter. For example, if you input T, the word Tuesday should print out. The code that is shown allows the user to input data and store it in the variable input. Use this variable to check the day for each. After you compile and upload the code, there is a section where you input the letters on the top of the serial monitor window. For loops can be thought as repetitive if statements, meaning they continue running if the conditional statement inside is true. If you look at the code above, the first line is how you format a for loop, and everything inside is the code that will continue to run. As you can see, the code first creates an int variable called num, which is equal to 0. It then checks if num is less than 10, and if it is, it will run the code inside the for loop and then add 1 to num. Take a moment to decide what the code will print out. When you run the code inside the Arduino IDE, it will print out 0 through 9 with a 1-second delay between each number. Now I'm going to go over how to control an LED with your Arduino. This code will probably be familiar to you because you used something similar to this in session 2. In the setup function, the line pin mode 10 output is telling the Arduino we will be using the pin 10. Inside the loop function, we use digital write in order to send a voltage through the pin 10. High means 5 volts will be going through the pin, and low means the voltage will be 0. You can think of these as on and off switches. This final activity could be challenging, but you should be able to figure it out. The goal of this activity is to have at least 3 LEDs that will turn on and off right after the other. The video shows how the LEDs should work. I want you to try to use a for loop that goes through each of the pin numbers. You can use the provided paper to look over how to set up a for loop and use the LED controlling lines. In addition, the schematic will be provided to you. Now you will run the code that is very similar to that of the final code. The only change is that we'll be using Bluetooth serial in order to send data wirelessly without the need of a cable between the Arduino and computer. By now, you should understand most of the code within the sketch. Copy and paste the code into your IDE and compile and upload it. You should first see the line PV device, followed by power and a number in milliwatts. If the number remains negative 3.28, there is a fault in your connection between the Arduino and current sensor. Alright, now that we have the Arduino connected to our laptop, let's pull up the Arduino IDE. And let's go to Tools and see if we're on the good port. Okay, we're on the right port. Awesome. So now, you can open Arduino serial code. You'll find this on our website to download, or you can copy and paste it. So we have it here with the baud rate for 9600. We're outputting the word power in milliwatts. Alright, so now we can compile the sketch, upload it, and let's go to serial monitor. Make sure that the baud rate is the same as in the code. As you can see, we have the power in milliwatts of the solar panel. And if you take your hand and put it over it, you can see it actually decreases. If you take it off, it goes back up. This concludes session 4 of the Current Solar Panel program, and I leave you with this quote: "Nothing in life is to be feared, it is only to be understood. Now is the time to understand more, so that we may fear less."